everyone. Good morning, good afternoon, good evening. I welcome you all and thank everyone for joining the session. I'm going to be speaking to you today about universal Flutter Accelerators. Let me introduce myself. I'm Lourd. I'm working as Director Technology based out of Chicago and a traveler. And I'm part of Travel and Hospitality and originally from XT Mobile Community, having 19 years of experience in mobility. This is my first talk in XT and super excited. And I'm happy to be part of this year event. This is a high-level agenda. We'll be taking you through 4 key items: the need for an accelerators and its benefits. Then I'll get into the design of reference architecture and automation core framework that we built for Flutter, the release plan, how community will get benefit. Finally, we'll finish up with a quick demonstration on how to kickstart your Flutter app development. Let's deep dive into the session. Before even talking accelerators, let's understand the problem. Since its launch, Flutter made a revolution in the mobile application development landscape. Also, Flutter has proven that it is one of the best tools for MVP development. If you have an idea, quickly build and release an app on multiple platforms through power of single code base with no compromise on quality. Collect the feedback, keep releasing the MVP product to achieve the rapid growth. But on the other hand, at Publicis Sapient, we deal with very large-scale enterprise-grade application, which is typically complex in nature, span across multiple years contract, and have large development teams, say 100 to 150 developers working on same code base to deliver multiple initiatives. How does Flutter fit into these kinds of business transaction applications? Now we need to answer 2 questions. Flutter is very new. We all knew. First of all, the number one, the question that we need to answer is Flutter capable of supporting large-scale enterprise-grade applications? The answer is yes. Flutter is being widely adopted by enterprises. There are many apps made with Flutter. According to Google, since April this year, 80% spike in Flutter-built app, and every third app is Flutter in Play Store. On the other side, if you see Flutter apps with payment integration, such as Alibaba, JD Finance, Nubank, all of them are already demonstrated, and these enterprises are willing to venture into cross-platform technologies with confidence in delivering quality product to their customers. Now, the second question that we need to answer is, are we ready to adapt as a Publicis Sapient? Of course, we have Flutter expertise built, necessary skill set we have. Even we hosted a first Flutter meetup early this year. We are almost there and in the path of establishing the engineering framework and best practices for Flutter projects. So to stay ahead of the game, we have to establish a proven architecture within the organization to have higher standards, consistent design across all the Flutter engagements, which will help us to reduce the redundancy, basically to stop reinventing the common features app after app and bring in the efficiency in cost and time. Thereby, we have a pre-built components which works as an accelerators to kickstart the development with no time by leveraging development and engineering accelerators. The reference architecture, the network modules, and set of common features made as a reusable components, part of the development accelerators, and DevOps and automations are built part of the engineering accelerator to speed up the development. Let's see our thought process and approach behind this. We were evaluating Flutter for highly rated native mobile application for a leading QSR global leader. Is that without a strong architecture foundation, we will fall short of engineering benchmark and client expectation. As I said, enterprise applications are complex, has a complex workflows and do a parallel development and have a long-term maintenance to support continuous enhancement. To handle these challenges, we need to have a robust architecture and engineering tools and processes. Let's understand how we built a reference architecture, how we drawn an inspiration. In Publicis Sapient, we are so successful with module and layered architecture. For Flutter, we inspired from the Lego architecture and brought the same principle and concepts to Flutter projects. And also we followed a clean architecture principle to achieve the separation of concerns. I'm not going to bore you with too much of information here, but I wanted to talk about key highlights of each layers. As part of this, we created a multiple packages in Dart to reuse across mobile as well as web channel. Part of that, we created a highly scalable, reusable network modules as a SDK, which provides out of the features like configuration, request mapper, response parsing, queuing, retry, API caching, and authentication challenges with markability. Also, you just have to develop your own feature modules and just plug into the SDK. And if you see the middle layer, the common UI controls and widgets and theming are made as part of the UI kit. Using these packages at the top layer, you have an app layer where you can go and create your individual modules. Each module is highly configurable. You can go to feature level configuration. We have an ability to go and turn off a module, or you can go and turn off a particular feature within the module. This ability is actually brought into this architecture, and basically we have a plug and play architecture that we have followed here. Also, we have made a well documentation. You can go and refer later. This architecture is powered with cross-cutting services like unit testing. We have dot analyzer to ensure the basic code quality has been covered, and then DevOps and automation. Let's understand engineering accelerator a little bit. For Flutter, the standard on-demand CI/CD pipeline is created on Jenkins using Fastlane. Created a single pipeline to support both mobile as well as web. Also, quality gates and build breakers are in place. It has an ability to push the build. Once a build is successful, all it is passed through the basic quality gates. Then it pushes the iOS and Android builds to the App Center and test flight. Also, it has an ability to push web artifact to the Artifactory server. Finally, we have integrated the automation framework as part of the pipeline, where you can go and automate a functional automation script. Let's see the design of Flutter automation framework a little bit. For Flutter automation, we created a framework called EFAT. It is Enterprise Flutter Automation Test, built using BDD framework, Cucumber and Gherkin, on top of the Flutter driver. The key features of these frameworks are it supports parallel execution on multiple Android and iOS devices to reduce the execution time. Also, we built a real-time load balancer, helps optimize the device usage. Also, it has an ability to take screenshot on every failure and attach to the test result. And it supports integration with test management tool like TM4J, and then you can schedule, you can run it, and then it pushes the test run to the results to the test management tool. And also it has an ability to generate the execute report and communicate to the Confluence and pushes the test result. And it has many more features. I'm just talked about only key features here. The benefit this framework offers is, it provides a better performance compared to APM-based framework. If you see the bottom table, we see 80% reduction in the execution when you use Flutter driver compared to the APM Flutter. Generally, APM Flutter drivers are known for, it takes a lot of time, especially on iOS devices, to find XPath element. But wherein Flutter driver, we are able to execute a script in a few seconds, especially for Android. You can see that APM Flutter driver for Android takes 1.1 minute, but wherein Flutter driver it just takes 13 seconds. Generally, iOS takes more time, but if you compare to APM takes 3-4 minutes to execute any script to find the element. But Flutter driver, we have definitely we see a great execution time optimization here. And another feature that it offers is the reduction in idle time of the devices. Also, it's a single framework. You can go and use the same framework for both iOS and Android, as well as this same framework can be extended to the web as well. And finally, last but not least, it has touchless execution, automated reporting. As I said already, it has an ability to connect to the TM4J, and then it pushes the test result to the Confluence and Jira. We have seen so far development and engineering accelerators. Let's see the release plan. We are happy to announce that the first version of UFA is available today for adoption with key capabilities. With this, any Flutter project can use this, and they can avoid 15% of effort saving. The second release that we have planned from 4 weeks now on October 11th, with additional capabilities like better telemetry analytics and offline capabilities. After that, it is open for Flutter community. They can utilize this accelerators also, they can communicate back to them, repository so that others can get benefited. Here is the repo details and documentation, the complete reusable components, and then the automation suite that I was talked about. All of stuff is available in Sapien Bitbucket. You can create a Dojo ticket and you'll be able to get an access to this Bitbucket. Also, the clear documentation is made, how this architecture is made, and then automation code framework, and then reusable component. The features of all these reusable components has been documented in works. You can refer document 177080, or you can search Universal Flutter Accelerators. On the works page, you can get the detailed documentation. Also, we are set up at DevOps. This is one of the Mac server that we have set it up, and in order to access, you need to connect to the VPN. Let's see the quick demo, how you can use these accelerators. There are two ways you can avail this accelerator. You can check out the repository, or you can go to the Bitbucket, and then you just rename the starter app or the skeleton app as part of the repo, and you can start adding your feature modules. Or you can create your own project and copy these packages into your project. So there are two ways, as I said, there are two ways you can do. One, you just have to check out and then rename the application, and then you can start adding your feature modules. The second approach, as I said, you just have to copy, and after that, just have to go to the pub spec, and then you have to add the dependencies. Basically, you need to add the dependents to avoid the compilation issues. So once you're done, you just you sync the project, and you'll be able to download the packages. Once all of that you've done, you just have to go to the main.dot and just import the SDK so that you can go and get the benefit of the network, the packages that we have built. And part of these accelerators, you will get default account module capability with sign-in, sign-up capabilities, and then profile. All of the pieces, is part of these accelerators. You can just use those, packages, and you will get the complete sign-up and sign-in functionality. What we are right now you're seeing is, just have to go and add, the SDK calls, and then you just have to pass the sign up information, and also in order to log in, you just have to pass the user ID and password. Once you're done, in few minutes, you will be able to run this application, and then you will get the base application created with completely ready to use, and the bottom tab based application where you can go to the settings and you can toggle between the dark mode. And as I said, if you go to the account, we are provided out of the box features like sign up, sign in. You can completely configure whether you want to go with only email based sign up, or you want them social. All these through configuration you can play around with that. Either you can do a compile time, or you can do the runtime. It will download from the server, and then it automatically the next launch it will done. What you see right now is we just created an new user, and once it is successful, you will be able to log in. We deployed a test server, real server, to demonstrate for the login and registration purpose. So once you log in, what you see right now is we have provided an additional ability where you can go to you can use the web view, and you can launch them any web page that you wanted to do it. So what you see is an Android app. Right now, what you see without making any line of code, okay, what you see is same app. You can go and launch it in, and the right hand side, what you see is iOS device, and the middle one is the Android, the PWA app, and then the left hand side is a responsive web. Even in PWA, you will get the same feature, same networking calls, all of them. You will be getting out of the box. What you see is right now, whatever you are seeing in Android, you'll be able to go on, play around same features in iOS, Android, and PWA. And even what you see right now is on the right hand side is iOS devices. You will get the same features. And now you see the responsive web. If you launch the same app and web, responsive web, you will be able to see the same feature. Let's see now, if you drag this browser and if you get into the browser mode, okay, we completely build these pages responsive to self-adapt to the device screen size. What you see right now, the bottommost part, the bottom tab navigation has become a side navigation. This completely, it is done in a single, source code, and based on the screen size, is automatically self-adapt. So the packages that we have built, it's completely written in Dot. It's seamlessly working in iOS, Android, and web without making any changes. What you've seen right now is, engineering and the development accelerator. Now, the second part of the demo, I just wanted to show you the pipeline that we have created. A single pipeline. It checks out, and then it goes and create APK, IPA, and web as well as, and this is completely configurable. You can choose to decide whether you want to build only for mobile, you can do that, or you want both, you can do that. Also, we have quality gates in place. We have set up a unit testing, and then the basic sonar quality and Dot analyzer also we have included to have a basic code qualities to be ensured before we actually push this build. Once it is done, then we push the build to the Artifactory. Final step is to do an automation. Let's see the automation. After completing the build, the automation framework right now, which we talked earlier, is trying to install the app on both iOS and Android. As I said earlier, we do a parallel execution in order to execute faster to get the efficiency. Right now, both apps are installed, and the left-hand side you see is an iOS device. It's launched, and Android app also launched. And now the script is trying to create a new user, and once it is done, then it's trying to log in with the same user. Now, in both the devices, both the users are logged in, and we are able to automate completely both sign up and login features. Once the execution is completed, a test report will be generated. You can view a detailed report along with the execution time for each script and steps. If there is a failure, you can further drill down to check which steps has failed with screenshot. We have an ability, to attach the error screenshot as part of this. Also, it has an ability to, to update this test result back to the test management tools. In a nutshell, with this accelerator, you will get both 4 benefits. Overall, one-time development effort, you'll be able to save 15 to 20%, and the reduction in project setup time to 4 to 6 minutes. We are already seeing the automation framework. We are able to reduce the automation execution time by approximately 80% through parallel execution. Finally, time to market will expedite by 20%. This is our core team. I would like to thank them for their contribution. And these accelerators are created outside of the regular work. Thank you everyone for listening.